आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Vigyan Ki Awaaz podcast series aims to popularize new ideas of science and technology, which highlight STEM, science, technology, engineering, mathematics, and medicine. This brings to the surface the efforts and researches of Indian scientists, which is desired to bring a change in community learning and teaching, access to knowledge of resources, and social paradigms. Our goal is to spread the name of indigenous Indian research stories and their masters among the masses of society in a very easy manner. Bose Institute was set up in 1917 by Sir Jagadish Chandra Bose, the founder of modern science in the Indian subcontinent. It is Asia's first modern research center devoted to interdisciplinary research and bears a century-old tradition. The institute was founded as not merely a laboratory but a temple, with its principal aims being the advancement of science and diffusion of knowledge. Swami Vivekananda, Sister Nivedita, whose influence is reflected in the institute's emblem of Vajra, was significant in the setting up of the institute, and Rabindranath Tagore were among those who had consistently inspired and supported Jagadish Chandra Bose in his endeavors. Ever since the establishment of the Department of Science and Technology, Government of India in May 1971, Bose Institute has been an autonomous grant-in-aid institution of DST. Over the last century, the institute has endlessly strived to preserve the legacy of its illustrious founder. In this podcast, we are happy to present Dr. Soumen Roy from the Department of Physical Sciences in Bose Institute. But before going into more details about his research work, let us hear from his own voice about his academic journey.
I'm Professor Soumen Roy. I did my PhD in statistical physics from Homi Bhabha National Institute. I did my first postdoc at the University of California, Davis in the Department of Computer Science, and my second postdoc at the University of Chicago in the Institute of Genomics and Systems Biology. Here at Bose Institute, I am at the Department of Physical Sciences.
Dr. Roy speaks on the area of his research in more details.
So today I'll be speaking about complex systems and networks. So what do we mean by complex systems? The systems that we studied in school, like a simple pendulum and systems of pulleys and so on, where there were not too many components in these systems. So come to think of larger systems, the human body is an excellent example. So there are so many organs in the human body. If you go down a level, there are tissues, there are cells, each cell is a factory in itself. There are so many components there, so many proteins are being produced, and yet all of these are working in such a nice harmony. So this is an example of a complex system. So the essential philosophy behind the complex systems is that the whole is greater than the sum of the parts. Now, networks play a very important role in complex systems in that they are the architecture of complexity. So what do I mean by a network? When I say network, I mean a collection of nodes and edges. So, for example, let's think of a railway network. So the railway stations would be the nodes in the network, and the connections between the two stations will be an edge in the network. So let me think of an airline network. So for example, there might not be a node between, say, Jaipur and Coimbatore, but there'll be an edge between Kolkata and Delhi. So all of these airports would be nodes in this airline network, and flights would be edges in the network. So now we can think of networks in almost every context. You cannot escape networks. So let me give a few more examples of networks. You can think of modern financial networks where there are banks, there are branches of banks, there are these users of banks, there are lots of transactions taking place within the bank, there are inter-user transactions, there are inter-bank transactions, there are international transactions. Nowadays, we have real-time transactions, IMPS, RTGS, UPI. All of them are taking place through a immense big financial network powered by the internet. So now come to the examples that we have done in our own lab. So we have used the methods of networking for image processing, non-invasive diagnostics, to get smart devices, and so on. So let me come up with an example that we did with the clinicians of Kolkata Medical College. So they were diagnosing a disease called the dry eye disease, and the process of detection is very painful. It's an invasive process. So they normally stick some strips into the eye, and obviously that's not pleasant. So we proposed a method of thermal imaging for the patients. So it was a double-blind procedure. We didn't know who was a patient, who was a normal person. So we did the thermal imaging of the person who was in front of us, and that video was broken down into a series of images, because that is what a video is. So from each of these images, we took pixel intensity, and these formed a time series. From these time series, we used an algorithm to convert it into a network, and just looking at these networks, we could differentiate between whether an individual is normal or a patient.
Dr. Roy speaks about his experiment and study on network, which has a great and direct impact on our life, society, and mankind as a whole.
So this is one example, one of the things that we did, and we converted this to proof of concept hardware device, which obviously forms the skeleton of a smart device. So the other things that are important for networks is how robust a network is, especially in the context of infrastructure. So for that we have given new measures to find out how robust these networks are. And obviously these will be important for electricity grids, infrastructure networks, and so on. And of course, there are many more examples in case of biology that we can think of. So for example, you could even think of proteins as a network. And because proteins are comprised of amino acids which fold into a 3D structure, and when they satisfy certain conditions and are within a certain critical distance, then you can place an edge between any two amino acid residues. So thus you can get a network from a protein, and by analyzing these proteins, we have made predictions which have been further verified in experiments. So these are some of the uses that networks can bring to many systems in our life, society, and nature in general.
Dr. Roy also explains how our country, India, will be benefited out of this research work.
So our country fares quite well in this area. So in both complex systems and networks, there is a good amount of research going on, and I think this is recognized internationally. And so using examples from my own lab, so we are working on smart devices, we are collaborating with clinicians, and network measures, we are testing the robustness of infrastructure networks. So all of these, I think, are fairly important in both science and engineering as well as in society.
Dr. Soumen Roy speaks on our global contemporaries and also the position of India he mentions in the global context.
Of course, the Europeans and Americans are there everywhere, but I think we compete with them quite well.
Dr. Roy also focuses on the benefit of the Indian industries.
Definitely Indian industry will be benefited. So, I mean, there are lots of results already which are ready for exploitation by the industry. One other thing that I want to stress on is defense. So, like, there are many applications as well to defense when we talk about all these networks. So, the defense sector can also benefit from our findings.
We are thankful to Dr. Soumen Roy for providing us with his valuable time.